Okay, so this video will cover the section B of the Set 3 Combined Science End of Year Paper 2021. So we will begin with section B. Section B, if I remember correctly, is about temperature and thermometric property. So basically here you are given a temperature time graph. Be very mindful that the time is given in minutes, not seconds. So if you are required to use formula like energy equals to power times time, the time need to be changed to seconds. Over here you will have temperature. So it says that this substance is a liquid at R. So at R, very good. You can see that the student is trying to combine all the info in one place. So this is a very good practice. So she actually worked backwards and she is able to identify that this flat line will turn the object into a mixture of both solid and liquid. In fact, she also have worked out that this means that P must be a solid. So Q represent a time whereby the solid is changing to liquid. So it means that this must be melting. And you can also see that from this, you can actually find out that this is your melting point. In another word, if this is the melting point, this will also be the freezing point. So just by reading the context, you can actually deduce many information from this temperature time graph already. So let's read on. So in part I, you can see that they are asking you to describe two things: arrangement and motion of the molecules in stage R. So what is stage R? Stage R is the liquid state. So you need to describe all of this in liquid state. So you can see that the student immediately identified that it is a liquid state. Very well done. Then after that, it says that the molecules are arranged in this orderly manner. Very good. Unfortunately, she forget to mention the packing order. So what do you mean by packing order? It is still closely packed. That's why in liquid, can you compress liquid? Cannot. Yeah, so it is very important when they are asking you about the arrangement, you need to point out it is disorderly arranged. So of course in solid it will be orderly arranged and things like that. And the packing order, is it closely packed or loosely packed? Next thing, she need to talk about the motion. So she say the molecules move around freely. Unfortunately, this is actually for the gaseous state. Okay, for liquid state, they cannot move around freely. They can only roll and slide over each other. So unfortunately, because the motion part, she got it wrong. And for the arrangement part, she didn't give me the complete answer. I can't give her any mark. There's no half mark. But in part 2, she has identified the right process. Like I said, it is melting. So she get that 1 mark. Okay, for part 3, very well done. This shows that this student has studied and she mentioned she answered the question completely. So the question is asking, why is it that even though the heater is on, but there's no change in the temperature? So if you look at Q, you can see that the temperature remains at 30, but the heater is still on. So what the student is trying to do is to account for this energy. So it says that the thermal energy that is being supplied is converted to IPE. And what do the IPE does? It is used to break the intermolecular forces. Very well done, 1 mark. Then can you tell me why the temperature is not rising? Because the energy is not converted to IKE. So what? So the temperature will remain the same. Yeah, very well done. But for part 4, I think the student got a bit nervous when she see a blank graph. So what you need to do is do it in steps lor. So here it says what? Substance is cool and it freezes completely in 8 minutes. So freeze means what? Freeze means it will freeze at the freezing point, right? Which is 30. So down here, the student should write down that, okay. So it will definitely hit 30 degree in 8 minutes. Then what? Eventually it reaches room temperature. So here it tells me what? So at the 10th minute, I should reach room temperature. Okay, so what is room temperature? Do I know what is a room temperature? I don't know. right? I don't know what is the room temperature. Oh, here it says room temperature is at 18, right? So this means that down here, my room temperature is 18 degrees C, and you can see that she's completely confused. So what to do? Do it slow lor. So what it means, at 8 minutes, right? So what I will do is, I always teach you like that, right? When we are supposed to sketch graph. Form a table first. It helps to calm you down. Some of you like to tell me that, oh teacher, I don't have time, I don't have time. You don't have time, then you don't do this, you got more nervous, you got the answer wrong, you waste your time. It's the same. I rather you do slow. Okay, what do I know? Oh, 8 minutes, I must reach 30 degrees C. At the 10th minute, I should reach 18 degrees C. Then what do? I draw what I know first, right? Which is these 2 points. So, 10th minute, 18 degrees C, I must hit this point. 8th minute at the 30 degrees C. 8th minute, 30 degrees C. So I know, you see, right? 8th minute, 30 degrees C. Once I have these 2 points, all I need to ask myself is it a curve between them or is it a straight line? That's all I need to know, right? So how should I do? Well, this thing will just cool until 30. Then what will happen? It will start freeze, right? It says freeze completely in the 8th minute. Okay lah. Then should I go like that? No, I shouldn't do this because it says I freeze completely here, right? I should freeze completely over here. So therefore, I shouldn't have this part, right? Then after that, what will happen? Oh, it will then reaches the room temperature on the 10th minute, or it only reaches it here. So it will go down, reaches room temperature, like that lor. Done. Right? It is not difficult. You just need to cool down, chill, have a system to actually have some anchor points. Anchor point is like this one over here, this one over here. This is called anchor point. Right? Once you have those anchor point, it simplified the problem. So I hope you learn from this if you are the student. Okay, for part B, you are actually told that this thing, the same substance, and it actually hit at a slower rate. And now they are telling you that there is a boiling point of 40. So if it hit at a slower rate, what will it happen? Well, the temperature rise. Will the temperature rise be fast or slow? Well, it will be slow, right? How about the time to boil? Will the time to boil be shorter or longer? It will be longer, right? Correct or not? So like I said, this student, very good in mathematics presentation, very good in calculation, study her content. But when it comes to new problems coming to her, she is unable to actually simplify the problem. So what do I mean by simplify the problem? This is what I mean, to break down the problem, right? To identify the keyword in the question and to break down the problem. And remember, always look for information. If you have information like that, we purposely put the key information at the top of the question. So if you are doing this part and you realize that, hey, what is room temperature? And you start to assume that, oh, maybe room temperature is 30. You're wrong. We want to train and see who is good enough to actually see that, oh, the key information is at the top, right? So down here is the same thing. We are trying to see whether you can break down a question into smaller pieces. What is slower rate? Well, heat rise is slower. So once you identify this, you break down the question into smaller parts. Now, let's change it and present it this way. Well, you started off at 20. The next point you are going to hit is 40, but because now you are having a slower hitter, you will reach 40 at a later time, right? So should you hit 40 over here or should you hit 40 over here, on the left or on the right? Well, if you hit it on the left, it means what? You are hitting the time. This is the original, right? Now you are telling me that your new hitter will bring your temperature to 40 at a shorter time. How can this be? No, right? So this is wrong. You should actually bring the temperature to 40 at a later time, right? Well, you can end it here, you can end it here, it's up to you, as long as it is slower. Then it will take a longer time to boil, so I make sure I take a longer time to boil. And then what will happen? Well, it will be slower, right? So you can see that this is my original line. This gradient represent temperature over time, right? This is the gradient, correct or not? Temperature over time. So now if you have a slower heater, it means that your gradient should be less steep, right? So that the temperature rise over time should be smaller. Right down here, if you look at the gradient, what do you do with the gradient? You take this point minus this point, right? This is your gradient, right? So what you are getting is actually the temperature rise over time. So if you have heating by a slower rate, then you will have a gradient that is less steep. So that's how you should approach part B. Okay, for question 10, basically is a giveaway. It involves very simple logic. You just need to be very careful. Okay, so for 10A, to find displacement, you just take final position minus initial. So this is the one. For 10B, you are asked to actually show me the average speed over average speed, and then you should show me the average displacement. So down here, you can see that she actually calculate the average displacement correctly. Use the displacement divided by time. So displacement, she found it earlier to be 50 divided by 17. This is the average velocity. Unfortunately, for the average speed, she do it wrong, and she got it wrong because here she used the wrong formula. Well, if you want to calculate this distance, which is in pink, it is half the circumference. So to find circumference is pi times diameter. In this case, the diameter is 40. Down here, this 20, right, is the radius. So that's why the diameter is this. And you are only traveling half the circumference. So you should divide by half. So down here, what happened is that you should have half times pi times 40. Okay, then after that, what you need to do is you have calculated the circumference, which is the pink part. You should add it to the blue part. So once you have this total distance, you should divide by total time. So I will leave this part for you to do in your calculation. Please show me your full working, and then I will mark your correction. Okay, for part B, it is your velocity time graph, and you are asked to describe the motion, right, which we have practiced extensively in class. And the trick I teach you to do is velocity, acceleration, combine it with one adjective, right? So let's see how to do this. AB, as you can see, throughout, there's no change in the velocity. Everywhere is the same, right? 2, 2, 2, 2, 2. So therefore, constant velocity. Right? It is not stationary. So if you see a flat line, a lot of you will think that, ding, my heart has stopped. No, this is not stationary. This is a mathematic graph. You read it as at 0 time, velocity is 2. At time equals to 10, velocity is 2. So therefore, velocity remain constant. That should be how you read it, not by the shape of it. Okay? BC, B to C. Excuse me. Excuse me. B to C. Excuse me. Maybe some student is cursing me. No lah, I think my student won't curse me lah. They are all good students. Okay, anyway. Yeah, so how do you do this? Well, at time equals to 10, speed is 2, velocity is 2. Time equals to 20, velocity is 4. What does this mean? Velocity increases, right? So, velocity increases. When I know that velocity increases, I know that it means that the object must have accelerate. Correct or not? Then how does the acceleration goes? Oh, gradient is straight. Acceleration is uniform. See? That's how simple it is. So therefore, it is not constant speed. It is constant acceleration. Right? Or in another word, you can also say that it increases at a uniform rate. It's the same as this. Okay? DE. DE, you tell me. Time is 30. Velocity is 4. Time is 40. Velocity is 0. So speed is, or velocity is, dropping. Velocity drops. The word to use is deceleration. Right? Straight line or curve? Oh, straight line. Therefore, deceleration is ... So I want you to show me the correction. Oh, okay, she got it right. Right? But you can also say uniform deceleration. They are the same. Okay? Okay, for part 2, without referring to the thing, state one differences between the motion of BC and FG. So let's see what is BC and FG. BC, the orange one. FG, the blue one. Well, here you can see that velocity is from plus 2 to plus 4. Here, minus 2, 0 to minus 2. What does it mean? Well, it seems that she has forgotten that velocity is an indication to direction of travel. So if you have positive velocity, what it means, you are traveling in the positive direction. If you have negative velocity, it means that you are traveling in the negative direction. Okay, so please do your correction over here. It is about the direction of travel. Okay, positive, negative. Part C, unfortunately, I think her weakness is always the distance. So you are asked to actually sketch the distance time graph in the first 20 seconds. I should start at 0, 0. You see, the graph already tell you start at 0, 0, but yet she starts here. So what does this tell you? By this point, she is already very nervous. She's not thinking, she's not reading the question properly. In her mind, she's only thinking, oh die, oh die, oh die. Don't do that. When this happens, chill, use highlighter to help yourself focus. Okay, for you, I highly recommend you use highlighter to bring your focus to the key, okay, the key data in the question. Okay, so here you also see that include numeric value of time equals to 10 and 20. So immediately what you do? Well, very simple. I told you, right? In class, I always do that. So I do not know why are you so stubborn to not follow me. Right? First thing I know, time is 0, distance is 0. Questions wants 10, I give you 10. I need to find what is this. Time is 20, I need to find what is that. So now this is my mission. Right? Once I have this table, I know what I need to do. Right? Some of you will say that, I don't know how to start the question. That means you do not even know what the question wants. Okay, so with this table, you know what the question wants. So now let's look at this. Time 10 and 20. Let's look for 10 and 20. Okay, got it. 10 and 20, you can see that she even put 1 and 2. So she has some idea. 10, this is the area. So what is the area? Area will be 2 times 10, 20, right? So I will go here, put down here 20. In fact, if I look here, I can see 20 is here. But she was so nervous. She immediately start here. What does this mean? She is lagging a system to think. Okay? She know what to look for, but she don't have a system to think. Okay, so later let's find out how do I do it differently from her and how she can learn from me. Okay, so first I found out that it's 20. Next thing, okay, when it reach 20, I will have this green color part. So this green color part, I have to find the area, which is half 2 plus 4 multiplied by the height of 10. So that will give me 2 plus 4 is 6. 6 times 10, 60. 60 divided by 2, 30. Right? So it means that down here, I would have 30 plus 20. Right? Because when I reach time equals to 20, actually this entire thing is the distance that I have covered. So I need to add them together. And actually I can see that though. You see? But she didn't know that she need to add them together. Okay, so now I have this. What to do? Well, like I said, anchor point. I know it has to pass through here. 10, 20, right? 10, 20. 10, 20, it has to pass through here. Then 20, 50. 20, 50 here, right? Now I need to ask myself between this point and this point, curve or straight line. So I look here, I can see that velocity is constant because it is flat. In a displacement time graph, constant velocity give you constant gradient, so I know it is a straight line, so I would draw a straight line. Next thing I refer to here, I can see that my velocity is rising, so a rising velocity would translate to a rising gradient. So I repeat myself over here because I know that my velocity is increasing between time equals to 10 to 20. So therefore I know that my gradient will be increasing from t equals to 10 to 20. So it means that it will be a curve, and I will curve it up gently like this, freehand and beautiful curve. So that's how you score this part. Like I said, as long as you have a system of doing it, get the key coordinate, draw the key coordinate on your graph as such, the green color one, these are my key coordinate. Then ask yourself, between this key coordinate, is it straight line or is it a curve? And you score. Okay, so you just need a system to tackle the question. So please do your correction, show full working. I know some of the, I know, since I'm the one doing the video, I know which part requires you to do your own correction. I will zoom into that and check.